It's Saturday night. Do you know where your desk of Lady Ada is?
It's right here. It's me, Lady Ada, and I'm here at my desk. I'm going to just do some light EagleCAD tonight. I have to design testers for 2 of the new feather wings. It's the relay feather wings, which I did some designing in a previous desk of Lady Ada. But now it's time to make the testers because the PCBs came in. So while I'm waiting for the components and stencils and all that good stuff to arrive, I'm going to design a tester. And then at work I'll mill it on the other mill. Maybe we'll stream that tomorrow. On Monday. But basically, every time we design a board, we have to design a tester for it. And that tester will check all the elements of the PCB and basically beep and turn on an LED if it passes. We get 99 or 100% yield on almost all boards, but it's still good just to test. You never know. I mean, especially like doing a first article inspection, it's always wise. And if you can do the test in under 10 seconds, then it's definitely worth, I think, testing each board. So let's get right to it. So let's pull up that design. So it's the relay feather wing, and I made 2 versions. I made a latching one. Turn off the bottom so it's easier to see. And this also comes in a non-latching type. So there's situations where you want a latching relay, non-latching relay. A non-latching relay, only when the pin is held high is the relay closed. So that's good if you want to have it only is on when there's like definitely a signal and that signal is kept on. And then it's simpler, it's a little less expensive. It's you only need 1 pin to control it. And then a latching relay has 2 pins, a set pin and unset pin. And so you toggle this pin high to set, and that latches the relay on. And then you toggle the set pin on, the unset pin, and that will turn it off. So you have 2 pins that you have to control up and down to control the relay. So, I have both versions, but I will also need 2 testers, 1 for each. So, it's not, there's not actually not that much going on. I mean, there's these pins, but I don't have to test these connections. Remember, the PCB itself is tested. So I only have to test the components, which means basically the 3-volt line, the ground line, and the signal, and then the outputs. So let's quit out of here. And then I have a folder called Other Mill PCBs. That's where my testers go. Relay feather wings. And I basically make a copy of the board here. And then what I do is I actually delete all the components because I don't need the components to test. Like I actually don't need this header output, and I don't need any of this. I just need let's delete that. I don't even need this relay. I only need the header output. And I don't need this or this. I mean, the only pins that are connected are these over here. And I don't need the silk screen. Although I like to keep just the name silk screen on because that's kind of handy. So I'll I'll leave the label over there. Delete this. So keep it nice and simple. I don't need all of these holes, and it's a little annoying to mill them all out. So I will change the dimension layer to be change layer to T-place. Oh, sorry, I don't have it's not a layer, it's an object. So I will create an outline. So this kind of shows where the device will sit on the PCB. And then I'll make, this is 0.1 inch diameter. I'll add the mounting holes. This will be used to align the PCB. And I'll show you what I'm doing. I'm doing, come on, there we go. And then I will make a 4-pin breakout And it's best to use oval holes because they just have more mechanical strength. And then I align this up here so it's aligned. And then I just delete this. Bam. So now all we're testing, I don't need all those other parts. I actually don't even need this reset button. And I'm not going to test that. That's pretty much it. And then to be nice, I will round these radiuses and then change this from a round to an oval PCB, which I kind of like. These are actually, I can also change these, although they're spaced enough apart, and actually they'll fit. I just happen to know that a pogo pin is 0.04 inches, and so you can see the holes are like exactly the right size. So I don't end up, like I can just use header and then I just solder the pogo pin in place. So now I have only the used signals for the feather wing, which is the relay output. Like again, I don't need to have the components on there because I'm testing those components. I just need the outline. And then I'm going to add an Arduino outline. And I have a very basic Arduino Uno shape. It doesn't have the, it's easy to mill. It's just like this. And then, I basically will have the Arduino in the center here, and then we'll bring all these pins out. So common, not open, non-connect. I'm just going to connect these to 3 digital I/O pins. So I'll make this simple. Just drag this over here. Oh, actually don't want these to route nicely. And it doesn't matter what pins these are, of course, because in the code, all I'm going to do is twiddle these pins and just check like which one's connected and which, when I turn the relay on or off, like I will check whether the pins are connected or not. To make the other mill happy, I used 24 mill traces. Obviously, I'm not going to carry that much current, but the milling machine requires large traces for ease of routing.
Maybe tomorrow we'll bring one of the other mills here so we can start to have other mill cam.
Yeah, we could do that. We could do it in the office. I mean, like I could bring the other mill over to my desk and it would just run on my desk or your desk. I mean, like it is a portable. Whoa.
Yeah, I think that we can.
What's going on there?
Oh, we have more graphics.
Okay.
No big deal.
That's cool.
So I think that what we could do is have the other mill here, and then also have one at the office. And,
sure. Either way.
Yeah, and what we can do is.
Oh, sorry. Tomorrow's Sunday, so you want to bring one home? I keep forgetting. For some reason, I keep thinking today's Sunday, and I'm like, we're going to the office tomorrow.
Yeah.
So we'll bring one here, and then tomorrow we'll mill this out. I understand.
Yeah.
Genius. You're the smart one.
That's not true. By hanging out with you, I got maybe one more IQ point, and that separates me from a huge majority of the animal kingdom.
Okay.
Not all. I think the dolphins and
Dolphins are pretty good.
I am competitive with dolphins sometimes.
Okay.
So I think what we could do is have a camera in it too.
Oh, totally.
And do some neat stuff with that.
Let's do other mill cam. Okay, I'm connecting the 3-volt because the circuitry on the relay feather wing needs 3 volts, and this would come usually from the feather, but this time I'm giving it from the Arduino, just 3 volts. I mean, it could be 5 volts, but I just want to be fair and give it 3 and just make sure, if it doesn't run on 3, it's a problem. And then the signal line, I just connected to pin 8. It totally doesn't matter what pin, but it's convenient.
Do you want to answer questions while I do this?
Yeah, sure.
All right. How do you handle doing vias with the mill, or do you just avoid using vias for simple prototypes?
I just avoid doing vias. If you've noticed, like I'm like routing lines so that they're like really large. You can totally do vias, but you have to like solder a wire through, and it's a little annoying. So I kind of just design things with large enough parts that I don't need vias. Like for example, I'm going to put a speaker on here. I like having a little piezo to beep to tell you that the board is tested and it works. So it just needs it will square wave and I'm going to just tuck it over here. I can connect this to ground, and like you see, like there's no vias, like everything is direct as possible. I'm going to connect this to ground. This is connected through the Arduino, but for care and kindness, I'll connect it through. And then I want an LED, so I'm going to grab do I have a 10mm LED. You know, I have a 5mm in my library that's a really nice extra wide traces. Let me simplify this, bring this down here. So I have a speaker and an LED. I think it's good to have two options for indicating when the test is passed. Lately we've been using more LEDs than piezos, but I always just put them down. And then for resistors, 1206 resistors are easily milled, so I like those. So I'll make this green, make this a 1K. This is just a standard piezo that we have, and then I can kind of put this LED here and then tuck the resistor underneath. You can see, like, I'm just making everything single-sided. It just makes my life a lot easier. And then I want to put in a reset button, and I like to use the Omron 12mm. They're just easy to hit. Sometimes, I mean, for this board, it's unlikely that it'll hang, but if the Arduino ever gets like in a bad situation, you can always just hit the button and reset the board.
Okay, next question. Do you really need the power of an Arduino to test something so simple? Couldn't you use discrete components right on the tester? I could, but I want to make sure that I test and toggle both. Like, you want to test that it's working when it isn't connected. I mean, this actually, like, but this is one of the ones where, like, you would maybe have a button to do it. But because all of our other testers use an Arduino, like, the people who do the test and prep are kind of used to, like, oh, the LED has to be on. Like, rather than have them, like, push a button to test both states, especially with the latching relay, it's a little bit more complicated because, like, I want to, you know, make sure that, like, when you toggle on, I want to have, like, maybe an LED visualization test. So yeah, I mean, like, this one, honestly, you probably could have just a button and, like, you press the button and it just tests the relay. And then when the relay lights, it alternates LEDs. But I'm still gonna do this because when I'm done with the test, I want it to also light up the LED on the board and have the person look for it. So I don't know. I mean, it is a little bit overkill, but, like, we have a lot of Arduinos, and I like this sort of standardization that we've come up with for testers. So that's why I'm going to stick with this. And, you know, honestly, even if helping Arduinos.
But, you know, even if I had to have a board that, like, tested this, I would still have to design a PCB to hold it with pogo pins. So.
Okay, next one. Don't you want a resistor for the switch?
What switch?
Oh.
The switch? No, this is it's just connected to the relay to the reset. And the reset has an onboard pull-up resistor, so you don't need it.
You know what you need?
What?
A capacitor.
I don't need any capacitors. Shush.
Okay.
So this is I could see how, like, there actually are some boards that we test without an Arduino that are so simple, like really basic breakouts, that there's no Arduino involved. It's just like you press a button, if the LED lights, basically it works. But those are pretty rare. These days, pretty much all the testers, I just automatically just design an Arduino for them. Mm-hmm. I think that's okay. So I'm going to put a dimension layer on here to box it in. And that's it.
Somewhere out there, someone is in a line at South by Southwest watching this.
Yeah, maybe.
somewhere.
Okay, so that's it. I mean, pretty simple. Yeah, basically. And the thing is, if I wanted to have it like beep, like I guess I could use a normal buzzer, but I don't know. I think I'm okay with this. Like, I don't, if I'm gonna have all my testers be Arduino based, this kind of makes it consistent, and I'm into the consistency. I mean, like this is very simple compared to like the Fona tester, which is like pretty hardcore and does like a whole bunch of stuff. Okay.
Here's what I have to say about this. Looking at a lot of the maker business posts that I do and reading a lot of things that come from Tindy.
Yeah.
Oh, by the way, maybe you could pull up the other mill site while we're here. Oh, or you can leave that. That's fine.
Other mill?
Yeah.
Other
that way,
machine co.
yeah.
Yeah.
That way folks can see it. Okay, yeah. So, one of the things that I see quite often is people saying, boy, the testing, if there's only like a way that I can make testers, because that's the hard part. And it's the barrier of entry for low runs for a lot of people. They can place the components themselves, or they can have someone do it. Then they're back to like, well, now I need to design a tester.
Yeah.
So something like an other mill, and being able to use something like OshPark will get you the PCBs that you need. And then for low runs of assembly, there's lots of places on adafruit.com/jobs that will do it, but also a lot of people do it on their own, but they still need a tester.
Yeah, I mean, testers are, like I'm going to have to design the tester for like the circuit playground shortly, and like that's really complicated. Like I have to test like 8 different things, so maybe I'll do that tomorrow, but I thought I'd take it easy tonight.
Yeah. No, this is super rad. All right. And with that, is your desk of Lady Ada.
Yeah, I mean, I'm going to just continue. I mean, like, we could continue and I could just do this tester. I don't know if you want to keep broadcasting or
No, I mean,
give people a break.
I think this is fine.
Okay.
We'll just remind folks, this is Desk of Lady Ada. We're also doing live broadcasts throughout the week. There's also Desk of Tony D. There's 3D Hangouts, Ask an Engineer, and Show and Tell. We are viewer supported. That means all of you are the reason that we're able to do this.
Yay.
Pick up some electronic kits and more. And also thank you for all the support for all these years. This is what we do. This is live right now. This is what we do on a Saturday night. And we have some interesting new hardware things coming out the door. And check out our YouTube channel and hit subscribe, youtube.com/Adafruit. And then if you go to hugvr.com/Desk of Lady Ada, just for another couple of minutes, you can see this set up in 3D.
Sweet.
So, yeah, all right. So that
Okay, I'm going to continue. I'm going to do the latching relay now. So just pretend. It's basically going to be almost identical, except what it's going to toggle both on and off and see to make sure that the relay works for both of them. Another thing that's interesting is, because I was thinking why not just have like buttons for the relay? And one of the things is that like every one of our testers acts the same. You put the board on and you hit the reset button and it lights up green and beeps. And I'm thinking what's the value in having we have 250 products and having all the testers be consistent. And I think that there's something because once in a while we have a tester that's not that way, and it actually has caused issues. Yeah,
I would say that unfortunately, the way that it works is this is never shared. We don't get a chance to talk to other companies about how they make their testers. And it is a little bit of the secret sauce that people aren't willing to share. I've never seen a live broadcast on the internet about making testers. And so what would be interesting is a innovator's dilemma, Clayton Christensen type person coming in and saying, this is what successful companies did testing electronics over the course of years, and they standardize and blah, blah, blah.
Well, what I have seen
not,
is whenever I do talk to people about their testers, it always ends up being like, oh, there's a laptop and MATLAB, and I'm like, you're crazy. There's actually like they actually have like a laptop with like with a DAC board.
We saw that at Apex.
We saw that at Apex,
Yeah.
and it's like, yeah, this is what you do. And I'm like, you have like a $3,000 setup.
It was more than that.
That could be replaced with an Arduino.
Yeah,
like
it was so weird. So it's a laptop, and then there's this box, and when you open up the box, it's just a million little modules that have pogo pins, and then they'll do consulting, and all of a sudden you have a $10,000 tester, and for like a $20 breakout board.
Yeah, I mean
that
sometimes
that would be nuts.
I totally understand why you would want that, but for something this simple, I mean, for all the feather wings, basically, check some analog voltages, maybe output to an OLED, or like light up some LEDs.
Yeah, and one of the things that I like is, we could say that this is a good idea the way we're doing it, but the results also speak for themselves. Our testers keep us out of having recalls and products that just go out wrong. Like, the testers work.
Yeah.
Once in a while, when there's like confusing stuff, like we make Arduinos, there's a chance that you can have the wrong bootloader, because we have the Arduino Gemma and also the Adafruit Gemma, things like that. But that's the only thing left that can possibly happen.
Yeah, and that's another thing.
And that's
where
pretty rare.
It's tester design. Like, you have to design it in a certain way.
Yeah, and so that might be down the road. I was thinking about some things that we can do. Like, do we ever want to have a tester when that we're figuring out like a VID PID thing, and we display it or a pass?
Yeah, we do. We have we've had the one of the things that's annoying about the Gemma is it doesn't enumerate with a mega ADK or 0, and so I can't have it auto detect. Yeah. Whereas I do that for everything else.
Yeah.
We solved the Gemma. The thing we actually solved. We only had that happen once. Actually, one time we had Flores go out without the bootloader. Had the test program, but because I had the test program was a little different, because you had to switch. Somebody the new person, I think, didn't realize that they had to, and so they thought like, oh, this is done, when actually it wasn't done. Yeah. So they didn't complete the test where it actually programs the bootloader. So there's
anyways,
things you learn.
Yeah, like if you're an electronics company and you watch this show, do a broadcast. It's pretty easy now. You just put a webcam into your computer. It doesn't matter. Just have get it close enough to the microphone. The knowledge is what's important here, and share how you're doing testing. Think of the human hours that are wasted on testers, and if you can help people test their products better, I think everything would get better. But it's completely unknown. When you go to a professional organization or show like Apex, they want to sell you a $10,000 thing, and that you can't. Our stuff is very reasonably cost and low cost, I'd say. That's why those big development boards from the big guys were like $200, because they're like 8 billion tests have to happen. It's like a motherboard.
No, it is literally like it's testing motherboard. I mean, yes, for those that it makes sense, but for the hundreds of items that we make, really an Arduino has been able to test almost everything that we make. Very rarely that you can't use an Arduino. There's a couple items that you need a Linux computer.
We use
for Bluetooth.
We use the Metro too. Like, that's one of the reasons we designed the Metro, because it's a more advanced Arduino-like thing for testing. Yeah. So it's like the hacker Arduino.
Yeah, I do use it for testing because it's got that FTDI and it's got the on-off switch. It's very handy. And the LEDs on the edge, because that way you can have the LEDs indicate activity.
Yeah.
Okay. Well, that's what I'm doing.
Okay.
So short broadcast.
It's like 30 minutes.
Just hanging out.
Got chatty.
Yeah, we're just chilling. Look, this is just a who knows, man.
Yeah. Well, like, I don't think when people start thinking about their business that they might get into, that the tester is the first thing. There's all sorts of things. It's just like, oh yeah, right. Like, the hardware is done. Now I have to test like 500 of these. What am I going to do?
No, you have to really think about the tester. It's the most.
I'll answer one last question before we go. Do you use a Raspberry Pi or BeagleBone Black for testing or automation?
I have, but it's rare. I tried very hard to avoid it because I don't like to involve a computer when necessary. I mean, there are some situations where you really do need to have like testing actually Arduinos. We use a Raspberry Pi because we test the boot. I normally wouldn't, but I use it to test the because we have to program 2 chips, and so I use the BitBang capability of the Raspberry Pi. Like we have AVR Dude with BitBang capability, and so it can program the 2 chips on board.
and then I do a enumeration and bootload. And to do that, I really want to make sure that I'm testing USB. And if you're testing USB, it's anything more than just enumeration. If you actually want to test like data transfer, which I want to do because I want to make sure that the bootloader bootloads properly, I use a Raspberry Pi for that.
Okay, unrelated question, but it's in the chat. Figured to ask.
Yeah.
Are you interested in ever making any synths again?
Not the same way as the 303. It's unlikely. There's so many other people making synths. I mean, like the Chromanius is going to be a Kickstarter soon. Like that's where you should go for synths.
Mm-hmm. I'll say this: since you did the Zoxbox, a lot of digital stuff has come really far.
Yeah.
Like it's really interesting. That being said, I think that there's probably a lot of kits out there now that there wasn't. Like what was it? Teenage Engineer or something. They make some neat stuff.
Yeah.
You know, there's some interesting
Like
kits
Atomic Teenage or something.
Yeah, like there's some interesting synths and things that weren't around when the Zoxbox came out. So.
Okay, well, I'll design a more advanced tester because this one is
Yeah,
a little simple. But we'll do the Circuit Playground one, and that will be a lot more fun to design a circuit board for because it's round. So I got to figure out how to clamp it. So it's going to be a joy.
Yeah. Yeah, Circuit Playground, we're going to get these to thousands of students, we hope, and hundreds of schools.
Yeah, how am I going to hold? I got to figure out how to hold this down. I think I'm going to have some clamp on.
We can get
two
one of those balloon filled with rice and then have it suction in there.
Yeah.
We can also get an inflatable robot to do it.
I'm probably going to just use like a side clamp thing.
Or side clamps.
All right, well, that's all I got. Any other questions?
That's
Okay, cool.
All right. Thank you,
I'm going to
everyone.
wrap this up, and then maybe tomorrow we'll mill this out.
Yep.
Good milling practice.
See you online and more. That was your Desk of Lady Ada.
Yay!